Hello everybody, welcome to this lesson, and we are going to continue with the one-dimension nanostructures explanation, and in this case we are going to focus on the properties that kind of materials can confer to the textiles. Okay, so if we move to this slide, we can observe that we have defined three kinds of one-dimension nanostructures that are used on textiles. It could be multi-layered silicates, graphene, and double-layered hydroxides. In this case, we can observe that it is that the long axis define the properties. It means that we have one dimension which is nanometric. In this case, it would be this here, okay, the dimension here. And we can observe that, for example, this direction and this direction are not nanometric. This means that we are going to obtain a flat and really thin surface. In this image, we can observe here that we've got the flat surface, okay, and it is really thin. Well, then, according to this, we can observe that, for example, multi-layered silicates are used to obtain nanopigments. This means that between the layers that we are going to obtain in that kind of multi-layer silicates, for example the montmorillonite, we are going to include part of the dye molecule, and then it's going to be kept there, protected from different external agents like the light or temperature. So this means that this kind of pigment could be protected, or it's going to be used to obtain different pigments trapped on that kind of particles, and this would allow to be used later on. But due to this possibility to include some dye molecules between the layers of the product, it's used also for wastewaters, because when we treat, for example, wastewaters from textile industry, they can contain some kind of dyes. Then, if we include that kind of nanoparticles inside the wastewaters, what we are going to get is that the dye would be trapped on the multi-layer silicate. Obviously, we cannot work with every kind of silicate and trying to catch or any kind of dye, okay? We need to study the chemical composition, the molecular size, so that we can include the pigment inside, or the dye inside the silicate, okay? We cannot, for example, we cannot introduce a big product inside a little box. In this case, it would be the same. If we have a dye with a big molecule, we are not going to be able to include it into the silicate, okay? So it's used, but it requires some study to know which is going to be correctly used. On the other side, when we move to graphene, we can observe that it is a kind of product, a nano particle, or a nanolayer, which is going to give us thermal conductivity, electrical conductivity, mechanical resistance, energy, the possibility to obtain some energy storage, and it could be used, for example, in electronics and many other applications. So what we are going to find is that it's going to give us new properties to the textile which is treated with that kind of products, okay? If we move to layer double hydroxides, we can observe that some of those products have been used as a catalyst for biomedicine, to obtain biosensors, to get antibacterial properties, and many other properties that could be obtained, that could not be obtained on a conventional textile. Okay, so this is going to help us to include new properties on textiles. Thank you very much for your attention, and I wait for you in the next videos in which we will deal with two-dimensional nanostructures.